Hello, today we'll be seeing how CRC is performed. Uh, Basically, what we have is we have a stream of message data. In that message data, I'll be choosing only a small portion of k bits of data, and I'll be calling it as data word. And I'll be passing that data word through a system, some logical circuit, wherein I'll be getting a code word. So my code word will be of n bit code word, and I'm basically translating a k bits of data word into a n bit of code word by just appending some n minus k bits of redundant bits, and this redundant bits is called as cyclic redundancy check. Basically, why we do the cyclic redundancy check is whenever I'm transmitting this k bits of data, uh, by adding or by appending some redundant bits, uh, at the receiver end, if I perform some operation on this n bit of code word, I can find whether my received data is having some error, or is it clear without error free, or like I mean to say it is error free, or is it error prone. So to check that, we basically add up some redundant bits, and that redundant bits is uh, calculated using a generator polynomial, wherein I am going to divide my data word by appending the data word k bits with n minus k bits of zeros, and I'm going to divide this whole data word. That is, basically I'll be taking k bits of data, and I'm going to append this with n minus k bits of zeros, and this whole will be my set of data, and I'm going to divide this with a generator polynomial, which is of the size n minus k plus 1 bit. So by doing this XOR division operation, I'll be getting a reminder. So basically this reminder is nothing but this n minus k bits of reminder will be available at last. So this n minus k is nothing but my cyclic redundancy check, CRC check. So what I'm going to do is I'm going to place this with my k bits of data. This will be the CRC, and this will be k bits of data, and this whole will be transmitted from my transmitter part. So at the receiver part, what basically my receiver does is it again takes this whole set of code word. I'm just simply writing it as code word, and again I'm going to do a reverse operation because this is again an XOR division. So I'm going to divide this with my generator polynomial. If the solution after this division, my reminder, what are the reminder I'll be getting, reminder, if this reminder is equal to 0, then it is error free. If it is not equal to 0, then it is error prone, and that particular packet of data will be discarded. So this is how general CRC is basically performed. So let us see how this is performed with considering a data. Let me take a data word as simply 1001, and this is my data. This is a 4-bit data, 1001, and I have to create a 7-bit code word. So what I basically have to do is I have to append, this is k bits, this is n bits of code word, so I have to append this with n minus k bits of zeros. So that is 1001 with 3 zeros appended, and I have to divide this with a generator polynomial. So this generator polynomial will be predefined. So in my case it is 1 0 1 1. So let us see how this division is done. So 1 1 ones are this 1 0 1 1. So this is just AND operation. 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is 1. And this is XOR addition or XORing of two data. 1 XOR 1 is what? 0. 0 XOR 1 is 1. 0 XOR 0 is 0. 0 XOR 0, 1 XOR 1 is 0. So what happens now is, if your leftmost bit is 0, then you are going to divide, or the divisor, all the bits of this divisor will be considered as zeros. That is 0 0 0 0. So you'll be ending up with 0 1 0, and this 0 will be coming and flowing here. Now again, checking your leftmost bit, it is 0 still. We're again dividing this with zeros, so that your answer will be 1 0 0, and this bit comes and sit here, that is 0. So now your leftmost bit is not 0, so you're going to divide your polynomial, generator polynomial, that is 1 0 1 1. So if I do this, it is 0 XOR 1 is 1, 0 XOR 1 is 1, 0 XOR 0 is 0, 1 XOR 1 is 0. So this is what I've ended up with. Again, my leftmost bit is 0, so I'm going to take the divisors as 0, and this gets cancelled, and it is 0 1 1, and finally the last bit comes and sits here. Since again your leftmost bit is 0, you don't have to worry about this basically, since this is the final answer, so you can neglect this. This will be your final solution. If you do the 0th part again, it is also not a problem. It is just 0 0 0 0, and you will be ending up with 1 1 0, and you don't have anything to bring down. So this is your final reminder. So this is your reminder. So basically you're going to consider this reminder, this is your reminder, and you're going to consider this reminder with your data word 1 0 0 1. So 1 0 0 1 is your data word added up with this reminder, that is 1 1 0, will be your CRC data. So if this data bit is received properly as such, and if you do the same division operation, that is like you take the generator polynomial at the receiver end, that generator polynomial will be dividing this particular data. So after this division operation, the remainder will be 0 0 0. Since this is the data which is error free, so your remainder will be 0. If in case this is not 0, you can try it out. Make any one bit as 1 if it is 0, or if it is 1, make it as 0 and do the division operation. This remainder will not be equal to 0, and it's hence understood it is error prone. So by this functionality, you can check whether your data has undergone any error during transmission, or is it error free. So cheers, all the best.